Okay, today we're going to talk about derivative. And the first one we're going to talk about is the basic one. It's called the power rule. Power rule is like this. The number are front of x to the whatever power, like n. Okay, so the power rule tells us, I'm going to tell you the formulas. I'm just going to write F for formulas. The formulas is equal to this. Actually, x to the n. Just x to the n. You bring the power to the front, minus 1. So let's say second derivative of x squared. How would you do this? Well, use the power rule, bring the 2 to the front, minus 1, you get what? 2x to 1 power. But just the 1th power is just x. So the derivative of x squared is 2x. Done. And we're gonna go over like two more of this. Let's say taking a derivative of a function. Let's say x to the 5th power. Well, again, use the chain rule, bring the power to the front, you get 5x. 5 minus 1 is what? 3. Just kidding, 4. So this is the answer. Okay. Let's do like 2 more because I got 2. Let's say derivative. You're taking the derivative of function 3x to the 10th power. Let's say to the 12th power. To the 12th power. Using the chain rule. I mean, you see a 3, but just like we taking derivative of this. This is just 1, but now 3. It's the same thing. Bring the power to the front, minus it. So you get 12 times 3 is what? 36. X, 12 minus 1 is 11. And if you want to prove it, take an integral using the reverse power, but it's not a video, but that's the answer to that answer. Okay, sorry. Okay, that's one. It's gonna be fun. Let's say second derivative of x to the 4th over 6. How do we compute this? Well, guess what? This is the same thing as what? Flip it, so you get 1/6 x to the 4th. Or you can imagine this is 1, like this, and 1/6 time it. But still though. It's easy, right? Bring the power to the front, minus 1, you get what? 4 times this, you get 2/3, I guess. Yeah, 2/3 x to the 3rd power. And we are done. Okay, so that is all for the power rule. Good. Now it's going to be the product rule. And product is the same thing as multiplication. The call is the product rule for derivative. And the formulas is equal to this. The formulas of a function a times b. Yeah, a times b. No. That's what f and g. F and g is equal to derivative of f times g plus f time derivative of g. So let's say, example of derivative of 3x sine x. 3x sine x. Yeah. Okay. So it's equal to derivative f. This whole thing is f. This whole thing is g. Derivative 3x. Let's use the power rule. Is the same thing as 1. Bring the power to the front, minus it. So you get 3x to the 0 power. Anything to the 0 is 1. So you get just 3. But x cannot be 0, okay? So first, you get 3 times g, just sine x. Add f, just 3x. And derivative of g, or g prime, you can call prime, is cosine x. If you want me, make a video of proving the trigonometry derivative, I'll do it. But this is the answer. Pretty long answer there, right? 3 sine x plus 3x cosine x. Good. Okay. Let's do like 2 more. Let's see. Okay, I got it. I'm just gonna write something. So we done the power rule, product rule, and this is quotient rule, chain rule, exponential rule. What rule? Okay, so let's say like taking derivative of 3x cubed time, let's see, natural logs of x. Yeah. Oh shoot. Natural logs of x. Okay. This is equal to what? This is f, and this is g. F of x, f prime x, prime f is equal to, use the power rule, minus 1, bring the power to the front, you get 9x squared. So you get 9x squared times g, which is natural logs of x, plus f, which is 3x squared, no cube, times g prime, which is 1 of x. And this cancel to a 2. So the final answer is 9x squared times natural logs of x plus 3x squared, and we are done. That's it. Okay. I think we understand a little bit here. Okay. Okay. How about this? Derivative of sine x. We didn't do cosine x. So let's do cosine x. And tangent x. This is a part of rule 2. This, which is f, and this is g. Right? This part of rule is equal to f prime, which is negative sine x, times g plus f times g prime, which is secant square x. So right here is the final answer. Okay, I think we get it a little bit, okay? I think we get it, yeah, we get it. All right. Next, well, we already do Oh shoot. We already do multiplication. So let's move on to what? Division. Yes. So we're gonna do the quotient rule. I don't really know how to spell quotient, so let me just go. Quotient rule. I don't spell quotient if I spell wrong, sorry. It's equal to this. The formula is U over V. This time we use U over V, not F over G. But we can use F over G. It's cool, it's cool. F over G is equal to what? It's equal to G times F prime minus G prime times F all over G squared. Sorry, my square looks so small. Whoa, okay, I'm just kidding. All right. Let's say you're taking derivative of the function x to the 7 power over cosine x. This is what? This is equal to x to the 7. Oh yeah, let me tell you that. This right here is F, this right here is G. So it's equal to G times F prime derivative of this. Can you calculate it? Yes, let's bring the 7 outside. And x. Let me write like this. I can bring this in front. So look nicer. Then minus G prime, which is negative sine x, but negative cancel. So then times F, which is x to the 7th power. Oh my god, I should write that. X to the 7th power. My bad, guy. It's my first video. I'm sorry. Over G squared, which is cosine squared x. And there's the answer. Very big answer, right? But here's the answer. Okay, next one we're gonna do is this. Derivative of natural logs of x over x squared plus 3. Using the quotient rule is equal to G, which is this, times F prime, which is 1 over x, then minus G prime. Derivative is what? This is just a constant, so always equal to 0. So you get 2x times F, which is natural logs of x, all over natural logs of x square. But can we do more? Yes, this link look pretty messy. This distribute this cancel to 1 power. So you get x plus 3 over x minus 2x natural logs of x all over, let's not write all over, let's write like this, times 1 over natural logs of x squared. And yeah, this derivative for so long. I know, guy. Next one. Derivative of tangent x. But this is not quotient rule, right? This is F, but over G. Where's G? 1? No. Let me tell you the answer. This is equal to secant square x. Secant square x. But if you know your identity, this is the same thing as what? Trig identity is the same thing as sine x over cosine x. Of course, yes. Using the identity, sine x over cosine x is the same thing as tangent x. So second derivative of this, you get G cosine x times F prime, which is cosine square x, which is cosine x, minus g prime, which is negative sine x, times f, which is sine x, all over g squared, which is cosine x squared. This is what? Cosine square x plus, this is what? Sine square x, all over cosine square x. Oof, this is such as nice. This is Pythagorean identity in trigonometry. I'm gonna make a video on this, but this, I'm gonna tell you, is equal to 1 over cosine square x. We're not done yet. Using the trig identity, this is attempting as secant square x. And we're done. That's it. Okay, so done with the quotient rule. Okay. Quotient rule, done. Now we're going to move on. Chain rule. Chain rule. You know how chain rule work? It's when you got a chain. I'm just kidding, but chain rule. Chain rule is equal to this. The formula is equal to f of g of x. It's a function inside of a function. And derivative, when you check a derivative, is equal to derivative f times g of x. Then multiply by g prime of x. So let's say we got taking the derivative of a function 8x squared times tangent x. Okay, it's equal to what? It's a 2 function. Oh, I was wrong. This is part of one. My bad. Please forgive me. Okay. Tangent of 8x squared. A function inside function. So this is f and this is g is equal to f of x. F prime, which is tangent x prime, which is secant squared whatever inside, which is 8x squared. Then multiply by g of x. Derivative is what? Well, taking derivative of this is move to the front, minus 1, so you get 16x. 16x. So altogether, this is the answer. 16x times secant square x times of ax squared. And we are done. Woo! 16x times secant square x. Secant square of ax squared. Okay, done. That's the first one. Let's see. Second derivative of natural logs of x squared minus 2. This is equal to f prime, which is 1 over whatever is inside, which is x squared minus 2, multiplied by g of x. The root of this is 2x. Well, you can bring a 2 on top, so it looks better. But here is the answer. Okay. Last one is pretty fun. Second derivative of natural logs of cosine of 5x to the 4th. 3 parentheses. Well, guess what? This is just chain rule. So you want to figure out what this first, then figure out what this. So this is what equal to. So let's take a derivative of this first. So we're gonna look at the derivative of cosine of 5x to the fourth is equal to negative sine of whatever this is, then multiply by derivative inside, which is 20x cubed. Put this right here so it looks cleaner. So we got it. All of this is this. Is this even harder? No, it's not. What is this? Product rule. I'm gonna clean this up. Is it still recording? I want to see. It's still recording. So, okay. So we're checking derivative of natural logs of negative 20x cubed sine of 5x fourth. So that means it's equal to what? Derivative of f, which is 1 over 1. Okay, let me write, expand territory. 1 over whatever that is inside, which is this. Let's put a negative in front, shall we? 20x cubed sine of 5x to the fourth. Multiply by derivative of this. Product rule. Let's do this. Okay. This is our product rule. It's equal to f times g is equal to f prime, which is negative 60x to the third, no, second, times sine of 5x to the fourth. Yeah. Time derivative of this. Use the chain rule, you get cosine. Then multiply by f, which is sine of 5x to the fourth. Woo! Okay. Tough. You can multiply this and this and this and this. This and this, you get negative 120 x to the 6th power sine 5x to the 4th. This term, but this and this same thing, so we can say square, then multiply by cosine of 5x to the 4th. Okay. So all together, this make a positive, so it's equal to, whoo, very big number. Okay, I need a lot of space here. That's a square times cosine 5x to the 4th. And you can figure out what this is because it's way too big. And I'm really tired right now. But yeah, that's the final answer. Okay, and we are done with the chain rule. And we're gonna move on the last one, finally, which is the exponential rule. Exponential rule is equal to formulas is equal to a to the x is equal to a to the x time x prime time natural logs of a. And this is 1. Yep. So let's say taking the derivative of a function e to the x. You might see this. It's actually equal to e to the x. And here's why. Keep it, multiply x derivative times natural logs of a, or the base, which is e. This cancel, this cancel. That's it. This is 1, this is 1. And if you don't know what this means, it's equal to e to the what power equal e. 1, duh. So that's equal to 1. Okay. What's our derivative of 3x? No. I want it easy first. Let's say 3 to x is equal to 3 to the x times x derivative times natural logs of 3. This is 1, so you get 3 to the x times natural logs of 3. Done. Okay. Move for the last one. And we're gonna do the last one, okay? Last one gonna be fun. The last one I think is gonna be take like 5 hours. I'm just kidding. Okay, this is how you solve it. Keep it. Time derivative of whatever this is, and you gotta use a chain rule, of course. Is equal to cosine 5x times 5, and derivative this. So multiply by 5 cosine 5x, then times natural logs of base. And you can figure out what this is, but that's the answer. Hope you guys enjoyed watching. Peace.